Hey everyone, it's Hank and Kate back with another 110 video.
Hey!
And this week in lecture, you all learned about if statements and while loops. So we're going to be covering those for you. So what I just typed out is the main method, and hopefully you all are familiar with this. At this point, you don't have to understand what all these crazy words up at public static void mean yet. We'll get there in good time. But all you need to know that is if you see this word main here like this, that's the main method, and that's where every Java program starts. So as we go on in the semester, our programs will get bigger, they'll have different files in them, and things will get crazy. But everything always starts at the main method.
Okay, well then let's get started. So first of all, we're going to start with if statements, or if-then statements. And a fun thing happened this past weekend for Mr. Hank Hester, and he broke his leg trying to hop a fence. Well, his ankle, to be specific.
So we're going to use my tragic experience as an example for everyone.
Right. So now that we are inside this main method, let's get started by making a new console. So we're going to say console equals new console. And we'll go into more of how this works when we get into classes later on in the class. But for now, we understand that that's how you set up a console. So we want our if statement class to tell the story of Hank breaking his ankle this past weekend trying to film something for Comp 110 videos. This is actually a true story.
Right.
So first of all, what we're going to do is we're going to set up things about Hank. We're going to decide if his leg is broken, what are his medical bills, and if he's drank milk. So we're going to set up Hank. And then we're going to go through the fence jumping incident and all the variables associated with that, like how tall the fence was, etc. And finally, we're going to see what the results were. We're going to print them out with our console. So let's get started.
Great. So we're kind of setting up like a programmatic representation of me. And the most important thing in this program where I jump the fence and break my ankle is my ankle. So whether my ankle is broken or not, that has a true or false value. So that means it's going to be of type Boolean. And we're going to name it if ankle broken. And we're going to initialize it to false because before Saturday my ankle was not broken. Great. Now, secondly, my ankle has to do with bones and things, and so it's important whether or not I had drank milk that morning. So that's also a Boolean value. Boolean drank milk equals, and we'll say
No.
false for now.
The final one is we want to know about Hank's medical bills because I think they changed this past weekend. So we're going to say it's an integer just because we don't want to deal with cents right now because it's just like if you have big numbers, we're just going to stick to the integers.
Right.
We'll say it was 0 before this weekend happened.
Great. So now we have kind of a programmatic representation of me. And if we wanted to, we could print these values out to the console and make sure like they were what we thought they were. But now we get to the point in the program where I jump over a fence. And whether or not my ankle breaks or not depends on a few things. And one of those things is the height of the fence.
Mm-hmm.
So we're going to set up a variable to store the height of the fence. And that's going to be an int. Fence height. And we're going to say the fence was 12 feet high.
It's a pretty tall fence.
Yep, it was a tall fence, Kate.
That was very adventurous of you.
Mm-hmm. So our program is looking at whether my ankle breaks or not. And that kind of thinking, we immediately know we're going to need an if statement. If the environment was one way, my ankle breaks. If an environment, our variables are another way, then, I walk away with 2 legs. So we are going to write an if statement. And starts out with just the word if, and then we put inside these parentheses any expression that evaluates to a Boolean. So the first one we're going to check is the fence height. So we're going to say if our fence height is greater than 10, then whatever we put in these curly braces will run. And
We'll say if it's greater than 10, you break your ankle.
Right.
Ankle broken is true then. And we're going to say your medical bills go up too.
Yep.
And we'll say medical bills go up by, I don't know, 300.
Great.
Perfect. So that was just an if-then statement. If it's greater than 10, then medical bills go up by 300. Do we want to run this with the console to see what's going to print out?
Yeah, so under results here, we're going to console.print.
So we're going to print out a question. So is my ankle broken? And Mr. Doctor console is going to tell us true or false. And we're going to also ask our doctor console how much Hank's medical bills are. So
Great.
let's print this out and see what happened on Saturday.
So if we run our program, my ankle is indeed broken, and I owe $300 in medical bills. It was not a good weekend for me.
Woo! We're going to start a Kickstarter fund for Hank.
All right, so now we've seen we can set up some variables, and what we thought would happen, right? So our fence height was indeed greater than 10, and so ankle broken was assigned the value of true, and my medical bills went up 300. And just to prove to you that it works, if the fence height were, say, 5, if I had tried to jump over a smaller fence, we press run, and my ankle is now not broken, and I don't have any medical bills. So that time the compiler got to this if statement here, it said, oh, no fence height is not greater than 10, and jumped to the end of this and printed out the values.
Great. Well, so we're kind of limited in this right now with an if-then statement. Let's add an else in to say, so if the fence height wasn't greater than 10, what's another possibility that could have happened? You still jumped the fence. It might not have been greater than 10, but I feel like you still could have rolled your ankle or bruised yourself a little.
Right, so I'm probably still going to need to buy some Tylenol from Campus Health. So we're going to add this else statement here, and it goes just right after the closing curly brace of the if. And we're going to say else, Hank buys Tylenol. And that means that my medical bills are going to go up by, let's say, $10.
Okay. And then what about your ankle? It's not broken, so we'll just leave it as it is?
Right.
So we don't need to say ankle broken equals false again. It already knows that.
Right, because we initialized it to false up here.
Perfect.
So now, remember our fence height is still 5, so we expect when it runs, it'll get to this if statement, say, oh, nope, this is false. This fence height greater than 10 evaluates to false, so we'll jump to the else statement and run this line. So if we run our program, my ankle is not broken, but I have $10 in medical bills.
Great. So there's a lot of variables happening here. It's not simply over 10 feet, ankle broken, under 10 feet, ankle not broken. A lot of it depends on how strong your bones are, and a lot of strong bone density depends on your milk consumption. So we want to say, even though the fence is over 10 feet, if the fence is over 10 feet, I have another question. Did Hank drink milk? So if drank milk, and you don't need to say, you could say equals true with that double equal sign, or you could just say if drank milk, because the computer is going to replace that value with true or false because it knows it's a Boolean. If drank milk, then his bones are strong enough, and I don't think his ankle was going to have broken. So I'm going to say instead, once again, just a little bit of Tylenol is all he needed. So medical bills equals medical bills plus 10. So this is a nested if-else statement. Well, right now this is just a nested if statement, right?
Right.
But we want to make it a nested if-else statement because we still want to say if he didn't drink milk, then that's going to happen. So to follow through with this once again, we're asking if the fence is over 10 feet, if Hank drank milk, he's not going to break his ankle. He's just going to need a little Tylenol. But if he didn't drink milk, which is implied by going to the else statement, So if drank milk is false, it's going to go to this else statement, and it's going to enter these brackets, and it's going to set ankle broken equal to true and medical bills equal to 300. So just overview, if you're not breaking your ankle, then you're only going to pay $10 in medical bills in our scenario. But if you are breaking your ankle, you're going to pay $300 in medical bills.
Right. And in order to break your ankle, you both have to have jumped over a fence that was higher than 10 feet and not have drinking your milk that morning. So let's look up here back where we were setting me up. I didn't drink milk that morning. And let's set our fence height back to 12.
So do you want to let them try and think through what it's going to print?
Right, so think through what you think this is going to print now. And if we run it, sure enough, my ankle is broken and my medical bills are 300. But if I had drank milk that morning, and say true, drank milk equals true, and run it, and that saves me from breaking my ankle, and all I have to pay are $10 in Tylenol. So now that we've gotten this far, our code is looking a little unwieldy. We've got some nested things. We've got like statements repeated multiple times, which is usually a bad thing, and it's kind of hard to read. So we're going to see if we can rewrite this in a way that's a little easier to read. So we've established that if you break your ankle, then you jumped over a fence that was higher than 10 and you didn't drink your milk. So we need to check two Boolean conditions there. And we can do that with our double ampersand. So we're going to delete what's inside our if statement here. And instead of just saying fence height greater than 10, we're going to say if fence height is greater than 10 and, so double ampersand, drank milk is equal to, and remember we use the double equals for checking equality, false, then ankle broken is equal to true, and medical bills equals medical bills plus 300.
Wow, that's so much more compact.
Right, that's a lot easier to read. And just as a side note, we can write this a little simpler. So instead of just saying drink milk equals false, we can use the exclamation mark to say not. That in most programming languages, the exclamation mark means not. So if fence height is greater than 10, and this just means drink milk is false or not drink milk.
Awesome.
So now, if we put drink milk back to false and run it, both
Ta-da!
Boolean conditions evaluate to true, and my ankle's still broken. So now we're going to move on to while loops.
Okay, so now we're in our main for while loops, and we're going to make a new console. And we're going to call this console push-up counter. So you don't have to name your console with a lowercase c. You can name it whatever you want. And we're going to name it push-up counter because what this console is going to be doing is it's going to be counting the number of push-ups that Mason is doing. So first thing that we want to do when we're making in our scenarios, you want to figure out what's the max number of push-ups that Mason can do. For how long is Mason doing push-ups? So Mason, how many push-ups can you do?
Let's say a solid 25.
We got a 25. So we're going to say int max push-ups equals 25. Okay, so let's go ahead and have Mason do push-ups with our while loop. So the first thing that you do with a while loop is you declare a counter variable and initialize it to 0. Usually our counter variable is the letter I. So int I equals 0. That's our first step. Okay, now let's go ahead and do our while loop. So while, we're going to go ahead and make it so that it will loop so long as I is less than the max push-ups that Mason can do. So while I is less than max push-ups. So we could have just written the number 25 there, but we thought it would be good to declare and initialize variables for practice. Okay, so we're going to have our push-up counter tell Mason how many more push-ups he has to go. So we'll say max push-ups minus I, and then We'll concatenate a string that says push-ups to go. Yay, okay. And then remember the last and one of the most important things about a while loop is that you increment your counter in the last line of your while loop. Because if you don't, it's going to be an infinite loop. It's just going to keep going because I is always going to be less than 25 if you never tell I to become one more than itself. And this statement that we just wrote, I equals I plus 1, is the same thing as writing I plus plus, which is just a shortcut of doing that. I plus plus. So we're saying I, add 1 to yourself. Great. Let's go ahead and run this. Wow, I wish Mason could do that push-ups that fast.
Right. As a reminder, if you want to slow down your console and kind of get a better idea of what it's doing, you can say your console.speed and set it to some double value here. So now it'll go half the speed. And this might be a slightly more realistic speed of push-ups to go. So if we want to add an if statement to our while loop, we can totally do that. So say just before we increment our I, we want to let Mason know when we're halfway. So we can say if I equals, and we'll go to 25, so we'll say that the halfway is about 12. Then console, no, not console, push-up counter dot print. We can see
Okay.
Oh my god.
Great.
The production value on these things.
So today we've gone over what are if-then statements, if-then-else statements, nested if-then statements, and we did while loops and showed you how to put an if statement in a while loop. We basically went over a summary of Comp 110 LFIT. We learned how to not climb fences, and we learned how to do push-ups. So we hope this helped everyone out, and
yeah, don't
stay
climb
safe.
any fences.
Woo!
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
Gosh, it's so impressive.